For as long as we have gazed at the sky, we have asked a single question that binds all of humanity. The ancients looked at the stars and imagined gods, spirits, and stories. Today, we look again, not with myth, but with mathematics and light. And somewhere out there, among the countless worlds, one has captured our collective wonder. A world not like Earth, yet not so alien that we can't imagine walking its skies. A place where water might flow, where chemistry may whisper the first quiet notes of life. Its name is K2-18b, a planet orbiting a faint red sun, far beyond our reach, yet close enough to make us wonder if the universe is preparing to answer that timeless question. In 2015, a small dip of light reached us from a distant corner of the constellation Leo. It was subtle, a rhythm repeating every 33 days. The Kepler Space Telescope had caught something. A shadow passing across its star. That shadow revealed a world, a planet roughly 2.5 times the size of the Earth, orbiting a cool red dwarf known as K2-18. It was close enough to its star to keep liquid water, yet far enough to avoid being scorched. Astronomers had found planets before, thousands of them, but this one felt different. It was big enough to have an atmosphere, but small enough to be potentially habitable. It lived in that delicate region we called the habitable zone, where warmth and water could coexist. And also, the story of K2-18b began not as a headline, but as a faint flicker in the dark. Years later, the James Webb Space Telescope turned its mirror toward the faint red star. Its task was not to take a picture, but to read, to decode the faint light that passed through the planet's air. When a planet passes in front of its star, a thin layer of light filters through its atmosphere. In that light, scientists can detect fingerprints of atoms and molecules, like reading invisible ink written across the space. When Webb analyzed the light from K2-18b, it found something extraordinary. Methane, carbon dioxide, and traces of hydrogen. But what made headlines was something far more intriguing. The possible hint of dimethyl sulfide. On Earth, this compound is almost entirely produced by living organisms, like tiny planktons drifting through our oceans. Finding it on another planet does not prove life exists there, but it does something else. It challenges us to look deeper, to ask why such chemistry might appear so far. In that single observation, humanity stepped a little closer to the unknown. K2-18, the star at the heart of this system, is a red dwarf. smaller, dimmer, and cooler than our sun. Its light would paint the skies of its planet not in gold, but in deep crimson. Red dwarfs are amongst the most common stars in the galaxy. They live for trillions of years, long enough for life, if it ever begins, to evolve slowly and steadily. Yet, they are unpredictable. They flare, they pulse, they emit powerful bursts of radiation that could strip a planet's air. And so, K2-18b lives under a fragile balance between the calm of its dim sunlight and the violence of its parent star. If life endures there, it must be resilient, hidden perhaps beneath the layers of clouds or oceans, shielded from the star's burst. This is no gentle Earth-like paradise. It is a world that endures, surviving in a universe that demands adaptation. K2-18b belongs to a rare class of worlds, known as mini-Neptunes. It's larger than Earth, but smaller than Neptune, a middle ground that we don't have in our solar system. Its gravity is strong enough to hold on to a thick atmosphere, rich in hydrogen and water vapor. Scientists believe beneath that atmosphere may lie a vast liquid ocean, stretching for thousands of kilometers. But this ocean could not be like ours. It might be dark, pressurized, and endless. An ocean without shores, where the weight of the atmosphere above would crush the mountains flat. And yet, in that deep and alien sea, something miraculous could happen. Molecules might gather, interact, and evolve, just as they did once on Earth. Here, life would not bask in sunlight. It would thrive in shadows, feeding on chemistry rather than light.